In this video we'll show you how we can import the DXF files for Wire EDM. So I've started the CAD system here, so I'm going to import the first DXF drawing and we'll choose this one. When you import DXF files, it's good to make sure that these boxes are checked, because we don't want it to have polylines. We want it to convert them to lines and arcs, and we want to expand any blocks. The units we're working in are millimeters. Okay, so that's imported the first DXF file. Now what we can't do is we can't import two DXF files onto the same drawing, so we have to do them separately and then copy and paste them in. So if we import the next drawing, and this one will be the top, and all these remain the same. Okay, so this is the second DXF drawing. Now because I'm going to be positioning this geometry onto another drawing, I need to create a point. So I go into point and select near, and then lock on to the datum position here. I need to do that so that when I come to create the contours, each contour can have the same datum point. So now I simply select that geometry and say copy it, go back to my original drawing and say paste, and we'll just paste it. It doesn't matter whereabouts this is. Okay, so now if we wanted to, we can view the properties and we can choose a bigger paper size. Okay, so we've got those two shapes there. So now we need to create contours of each one. They don't have to be coincident on top of each other, and in a lot of cases it's better that they are separate because you can see things more clearly. So the way that we create the contours is we go into CNC mode, and you'll notice the first one has its datum position in the original position here, which is what we want. So now we go into create a contour, and we'll lock on to this top line here, and we'll call this contour bottom. So that's created that contour. Now we can change our datum position to the point that we created previously. So that's the datum for this contour, which has the same start point here, but this contour will be called top. So we have two contours there. Each one has its own datum, but the system will make them coincident when we go into the EDM software. So let's save that way. So now we go into machining for the Wire EDM module. So as you can see, it's created those two contours and used the datum position to make them coincident. What the software will do is when it sees contours within the drawings that have been created, it will create a two-axis program for them, but we don't want that, so we can just switch those off. And what we want to do is we want to create a four-axis job. So we choose the four-axis tab here, and we choose which contour we want. So the XY contour will be this one, and the UV contour will be that one, and we named them as we wanted to. We can set up the distance between them, say 20 millimeters, and under the options tab here, if we start machining here, it'll consider this first span as part of its approach movement and apply all its offsets to that. So what we may want to do is we may want to create a start hole position, in this case 5 millimeters away from that, and then the lead in, lead out from that start hole onto the contour can be linear, or it can be linear plus arc, and if we set the radius, and the same thing at the runoff, the lead out. So going here, we set the direction of cut and we set the offset. So if we're cutting around the outside of that, the offset would be to the left. And there are other features that we can use here for rough, finishing and middle cutting. So in its normal format, what that does is it creates a program for that shape there. So it creates a rapid movement from here out to the start point. It puts an arc approach on, machines all the way around, and then when it gets to the end, it puts an arc lead out on. If we want to animate the wire, we can do. So that's now running along the top here, as you can see. And it may or may not be that those synchronized points are where you expect them to be. If they're not, then we can add in extra points. Okay, so in the right hand corner here we have the maximum cut distance and we have the maximum angle and deviation on that program. So now if we want to add on synchronization points, we go to synchronize. The XY contour is that one and the UV contour is that one, and now we can add the synchronization points on that we want. So this will be forcing the wire to synchronize at these positions. So what it does is, as I'm choosing the synchronization points from each contour, it highlights that contour such that it's easier for me to choose the synchronization points. And when we're happy that we've got enough of those, we simply click run. Okay, so that's produced that program. We can look at it in the isometric view and see it. We can post-process that for the required machine tool, or we can run the 3D simulation. So for the 3D simulation, we can leave all the defaults as they are, and we simply click on Simulate. So this is showing us the part plus the nozzle at the top. If we want to, we can make the upper spindle transparent and we can make the lower spindle transparent as well, so we can see that. The video controls across the top here control the animation. So that's the rapid movement. Okay, if we go down to the measure button here and we say select remove chips, press down on the mouse wheel and that will get rid of the outside stock and just show us the part as we have machined it there. Under the move list, you can run the wire back all the way around there. So you can see exactly what is happening there. Okay, so that's the verification that we can see there, and that looks just like what we want it to machine. So we can go File, File, Exit, and then we can post-process that to the required machine tool. Let's choose a standard FANUC, but we have a range of different machine tools, and what then happens is that G-code file is produced for you at the bottom of the screen here.